Hello. Okay, I'm going to share my screen. Second, I will close everything wrong. Right, let's get started. Can you hear me? I'll copy paste the link to this document into chat. Today is not so many people, but anyway, welcome everyone on bi-weekly community meeting of developing Cozystack. I'll repeat that we have Telegram group and Slack channel where you can join and ask your questions. We probably don't have anyone new on this call. Please put your names into the document. Feel free to do that. Today we have a few topics to discuss. First, you probably already found that we have a new logo. We already replaced it I think everywhere. We also will ship a new Cozystack version. Hope you like it. This new logo has this issue when people just get confused. These 3 lines in the middle, and it has a logo instead of it now. Many thanks for participating on CozySummit. I think we'll publish videos in 1 week or something like that. I'm a little bit confused because Timur just put this topic and he didn't came to this meeting. I think we can swap it to the next one. Yeah, for now we are working on joining CNCF Incubation. Right now we are still in Sandbox, but we are in the next, I think 1 or 2 in queue to consider joining Cozystack to Incubation. We are working hard to improving security, improving processes. So there is some something going to happen, I think. And I'm going to share you my screen again. The Blockstor. There is a new project. It started as an R&D project. The idea was to rewrite LinStore on Go because from my point of view, it has some issues in big scale. Actually, LinStore is based on request-based model. It, for example, if you have 100 nodes, you push give me a size of all of these nodes, it will go in one time to all 100 nodes, collect the information, and respond it to you. If some node just will tag for a while, you will wait until your request is coming. So the Blockstor, its idea to rewrite LinStore on controller runtime and Kubernetes native design and still be compatible with LinStore API and LinStore tools. It's written on Go. It is very thin, and it already includes a lot of things which supported by LinStore. It still does not include some features like scheduled backup shipping, but the more important thing that now it can manage DRBD, it can manage Lux encryption, do the snapshots, and have this block level working. And I have a short demo how it looks like. There is a my console, and I have test cluster running here. This is very thin cluster. It consists of 3 or even 4 nodes. Has Blockstor system namespace, which includes the components of the Blockstor, and it also have Piraeus data store namespace, which includes the default Piraeus controllers. Piraeus is the project behind the LinStore, which provides you CSI driver and integration of LinStore and Kubernetes. So if you'll check the pods inside of this namespace, it has some things like CSI driver, Piraeus operator, which manages storage through the LinStore API, HA controller, which does fencing. Once node is die, it will remove the pods to let them reschedule to another nodes. Affinity controller, that's a thing which manages node affinities in case if you change and relocate volume replicas. And as you can see, there is no LinStore controller and no satellites running. In Blockstor system, we have these 3 type of services. We have Blockstor satellites who runs on every node. They actually manage LVM, ZFS, and DRBD, and apply the kernel configuration. We have Blockstor controller, which operates with the most default logic, like for placing those replicas between each other, do the failover, and do some periodic tasks. And we have also API server. This API server actually compatible to LinStore, so I can run port forward to this API server pod and use ordinary LinStore command to get access to the Blockstor itself. The LinStore thinks that it communicates with the LinStore, but in fact it uses Blockstor running in this Blockstor system. In fact, it is compatible with Linstore, with CSI drivers. For example, I can create PVC. Let's call it demo replicated 2. And it will be provisioned through this Blockstor storage. We can check replicas. We have 3 replicas created. Right now they have DRBD configured, and they are actually replicated. So for example, if we run pod, let's call it demo replicated 2. It will be created and using this volume. And you can see that this volume just switched to be in use mode. In fact, it used DRBD under the hood instead of, unlike of Linstore, actually every pod of Blockstor is controller. So controller writes any requests, it allocates the ports and DRBD minor numbers and satellites, also controllers who works with the same resources and just make them running and create it on the nodes. In CRDs, we have this amount of resources. They represent the same resources we're having in this API. So for example, we can see the created resources. We can see created nodes. And they all are normal Kubernetes YAMLs, normal Kubernetes first-class objects, because in Linstore it is not recommended to operate with their internal resources. In Blockstor, actually, we created first-class resources, which you can use for configuring and managing the resources created in Blockstor. They represent the states. They represent the actual configuration, the expected one. And for every resource in Linstore, for example, resource definition, we have specific resource in Kubernetes. That's it. That's not very stable yet, but some features already supported. For example, RVX. I think that should be already working. Let's check it out. I have volume created. This one. The same way, like in Linstore, they take this volume and they expose it in the pod as NFS here. Yeah, unfortunately for now it is not working, but I think I will fix it soon. So actually, in fact, 2 pods will be created and they will be working with the same volume. Also, it is possible to create local volumes. You can see there is a layer stack, so you can use only storage, underlying storage, and use no DRBD in case if you don't need to have a replication. Of course, you can create replicas directly through the Linstore API. For example, I create a resource definition, I create one volume in this resource definition. And now I can create 2 replicas, for example, of this resource. Now they should switch to 2 replicas, and the third is tiebreaker, which is used as just to ensure the quorum between those 2. And you can manage it somehow. For example, you can create another replica, example, on the node 3. And remove the replica from node 2. Again, now you have just 2 replicas. So relocation also works. That's pretty much it. This is still R&D project. If you're interested, you can join. For now, we have prepared pipeline with a lot of tests. And those tests should cover almost, I think, all the cases. So it includes lint and unit tests. It also has specific integration tests which runs a kind cluster with no actually DRBD, because DRBD is running on kernel. Those tests just covers the cases, for example, creation metadata, but not actual replication, and contract tests which check if LintStore client and LintStore API is not broken. Then we have 6 lanes of end-to-end tests. Each is done by, I think, from 10 till 20 minutes. And the last case, we run Piraeus, actually, and trying to provision persistent volumes from the Kubernetes. So feel free to create your pull requests, test this project. Maybe in a while it will replace LintStore in Cozystack.
Hey, Andrea, I have a question regarding tests. So, are there any tests destructive or that imitate some issues in any environment? I mean, like production environment, some loss of connectivity issues, something like that. Because I believe
we have few tests regarding this. Actually, that was quite difficult to collect a good test base. But actually, thanks to AI, I used few sources, my old presentations and articles about LintStore. Also, I feed it the community channel of DRBD.ru, which is used where people just solving their issues. And also official documentation knowledge base. In fact, it generates me I think 200 tests, including some difficult scenarios. But of course, feel free to contribute tests if you think they are.
It was quite funny here in the DRBD room and solving issues chat.
Yeah.
Okay, but I get it.
Also,
okay, thank you.
Also, I think that this solution should be working fine on Raspberry Pis. It includes RAM-based architecture, so I think DRBD module can be simply integrated on Raspberry Pi because it is kernel module, and you can try to use Blockstor on these thin and small devices. If you have this experience, please report if it works or not. All right, then we also have a OpenFloor, Declarative Talos with tofu-controller. Yeah, Max, you have a hand raised?
I have one question about Blockstor.
Yeah.
So what's about functionalities? I see RVX at current moment is broken, but what already works and why and what not?
Actually, it was working. I think there is some regression regarding this. Here is a current status described. So we do support various backends, LVM and ZFS, also file backends for testing. It can work with no DRBD, with no replication. It supports LUKS encryption, do some jungling with placing the replicas, relocate them, automatically place in different zones in the same zone according to the configuration. It allows you automatically configure tiebreaker and quorum policies. It also does the snapshot creation. Implementing snapshots was quite funny because in order to make snapshot, you need to freeze replicas and then create snapshots on all three backends and then unfreeze. So in case if you have synchronous requests, it works fine, but in controller runtime, it's slightly challengeable. And various things like you can receive, you can send snapshots between inside of the same cluster, but not in outside cluster yet. You can resize volumes. So in fact, I think it allows you the mostly ordinary tasks with provisioning volumes. It's not super stable right now, but I think we will solve that in a while.
Yes, thank you. It's awesome solutions, and I think maybe in future we should provide alternative storage layer, like you can select a lint store or new block store. What do you think about it?
Yeah, I think we could actually easily migrate LintStore to Blockstor. And once we decide that we need to replace it, it might be way more easier to support just a single solution. Actually, supporting LintStore a little bit painful, quite difficult to contribute fixes to upstream. Yeah, for now, you can just download all the configuration of LintStore, reconstruct it a little bit and upload to Blockstor, and actually it should be working as it is. You don't even need to change CSI driver.
And I have yet a question. It's already have a migration tool or not?
No. We don't have any migration tool yet, but I think it will be created in a while. For now, it is like R&D project, and we just push it to the community to help us to test it and stabilize it.
One more question from my side. I'm kind of confused because this project is regarding data storage and it is pretty wide coded. Maybe you can say some kind words that can assure me that it is worth using.
That was an experiment. Yeah, everything here is wipe coded, but this code is guided by me. Actually, in difficult cases, it was needed my attention to explain how the things work. And actually, AI is just a tool for write a code, not the logic.
And I think it's not vibe coding, it's already agentic engineering, because I see on the stream that it's already have architecture, writing tests. It's not create lean store in Go, make no mistakes. It's a normal project, I think.
Okay.
I don't know. Actually, I
Mhm.
don't know. I can't commit that you can use it in production yet. I think in a while when we will test it,
I think I will test this with OpenClaw for with a task. Please broke Blockstor and write issues.
yeah, that
Okay.
might work. But under the
And
hood,
mhm.
yeah, anyway, under the hood, it used the same ZFS and the same DRBD. So it just replaces the control level, which creates the volumes. DRBD itself has some safety checks to not break the replication. We only need to configure it properly.
Mhm. Yeah, that's what I wanted to talk about a little bit, because on the underlay, it uses the same old DRBT and it is just a control plane, as I understand, right?
Yeah.
Okay, thank you.
So there is no data plane at all. There were an idea to create, to extend it with new backends. Especially, I really interested for adding shared loon provisioning. That's an option when you can connect one loon from the sun to multiple nodes and just cut it for small pieces and have QCO running on top of this LVM. This could bring you snapshots, and as far as I know, those snapshots are faster than LVM thin snapshots. And another option is to use VDUs backend. VDUs is new generation of, I would say, loop devices. You can run daemon, which works in user space and will publish and write any custom logic, which will publish it as kernel block device. So feel free to join. Thank you for your questions. Let's switch to OpenFlower. We have declarative Talos with tofu-controller. Not sure who put it here. Could you please represent this topic? Probably people is not here. So let's move it to the next day, next community meeting. The second topic is potential.
It's my topic. So can I share a screen?
Yeah, sure.
A few seconds. So you're seeing.
Yep.
So what's the idea? So Cozystack already have backed by aggregation API layer feature like translating API resources like Redis, Postgres, Kafka, etc., to Helm release. It's a very interesting feature for managing resources inside of Cozystack cluster. But I think for Cozystack, nice to have a feature for managing something outside of cluster. So what I mean, for example, you want to create a GT instance, and you want to configure your organization inside of Git. So in current realization, you should create a Helm release that actually deploys the KT and job with the bash script for configuration. So I want to implement a Terraform-based approach for configuring applications. So checked my first draft. So my motivation, what if we mapped API resources not for Helm releases and to Terraform. So for example, we have definition and have a schema, like we have seeder and region. So when we create VPC resource, they under the hood create Terraform resource from the tofu controller and takes Terraform code from the Git repo and configure your Helm releases or deploys Helm charts or go to Cloudflare via Terraform providers and configure and return some status about the result. For example, it's already good or not, or something went wrong.
That looks very interesting. Where is the state stored?
And I think about two implementations, how to implement it. So I have two drafts. First is we don't change current application definition and make a parallel stack. For example, we have a tofu application definition with kind, singular, plural, open API schema, and some Terraform template for Terraform resource. Or we can decouple our application definition for which allow us to extensible like a providers for create something in real world. For example, with Pulumi backend, after creating a resource, we can run Pulumi code for creating in cloud or inside cluster, or maybe mapped one resource to many other, and etc. etc. So I think what draft more actually good for Cozystack. What do you think?
I not very understood where is the state is stored of the deployed applications, of deployed resources.
State. So I based on on Terraform controller from Fluxity. So it's if I know correctly, it's saving state in etcd as a secret, and if he is providing status or special secrets, for example, connection strings or something else.
That's interesting. And in order to be able to deploy resources, you need to have a Git repository. Am I right?
Yeah, you should provide some repository, or it's already based on Fluxd repository. For example, you can have OSI repository or Git repo. For example, we what source ref. It can be Git repository, OSI, or S3 bucket, or something else. What do you want?
Yeah, that
For,
sounds interesting, but I don't really understand the use case. I think we need to start from the use case, what the problem we're solving right now.
I yeah, is this solve a problem for you have many providers. For example, you want to when you deploy Git configure organizations. In current approach, you should create a cron job or cron job for configure. But in my approach, uh, you can configure from one code. For example, via Terraform, we can Helm release, and after configure via Terraform code Git instance via providers.
and it can be configured through the Terraform. I see another value that actually you can use Cozystack as a control center for multi-cloud. So you can, I guess, with this approach, you can provide many templates for ordering Kubernetes clusters and managed databases
Yeah,
from the other
yeah.
clouds.
This actually a lightweight alternative for crossplane, because crossplane it's a huge project with heavy logic inside of it, and crossplane have some problem like CRD bloating. And I think providing some one resource that configure via Terraform all cloud integration, I think it's a better way because API server don't DDoS by many controllers.
Are you sure that FluxCD controller didn't work that way? Don't
Um,
work that way?
no, I think it's not great many custom resources in and not great many reconcilers under the hood. So I think this solution is more lighter. Uh,
Yeah, in fact, everything you're having here is still Terraform resource. The problem of Terraform, it was not designed to work like in reconciliation loop. I think it might have the same issues. Imagine you have 2,000 of resources and you instruct Flux to reconcile it any minute. So every minute you will have 2,000 of requests to the cloud API.
yeah.
So I'm not really sure that that will solve it that way. From another point of view, you can still use Helm releases and just put the same YAMLs into these Helm releases. I like the idea of having it like optionally, but it will create additional load on the team for supporting this with no clear use case. So we need to find a problem first, which we're solving. And that's a really cool presentation. Thank you. I didn't know about this solution, but now we need to find a problem. Why can we apply this approach?
So thank you for your opinion.
Yeah, if somebody else has opinion, also please feel free to share. We have a question from Miroslav. He's asking, is it for GitOps or for IDP internal developer platform?
So I think this is it can be used for a IDP or for a GitOps approach. So I imagine this solution as a lightweight crossplane without many controllers and just a single reconciler that spawns Terraform worker for reconcile Terraform state.
All right. Also comment from Daniel. I think it is alternative for classic K8s operators. Also, it could be used to manage cloud, as you say. And Marianne just wrote, this requires a deeper look to understand what it does. Thanks for presentation. You can actually submit it as a proposal to our community repository. For now, we
Yeah,
already have few things committed there.
yeah.
But
I
this,
will have already have a proposal in community repository. Is all material about about this?
Yes, Daniel, please.
Hi. On my I ran into issues with TerraGrant and Terraform itself. Like it has no built-in GitOps like instrument approach, and Flux tofu-controller like resolves this issue, and at least we can have this stuff controller as I don't know, like optional package for Cozystack.
Yeah, the idea of Maxim is to change the logic of Cozystack API server to work not only with Helm releases, but also with tofu applications. I think I actually like this idea. We can definitely expand it to support other Flux controllers. That would allow to people actually use customized tofu, Terraform, Helm, and whatever else with our API. I just trying to find the there are still issues in that. For example, you can't create dependencies between Helm charts and customizations, and it's also definitely will create the more load on the team. So I would like to maybe create additional API server and just teach our dashboard to work with that. Not sure if you need to keep it in tree. But again, we just need to find out the issue we're solving here.
Yeah, I know.
Yeah, more use cases will be helpful. I don't read your proposal, so I will look forward to it.
My thought about this approach, I feel like there is a better way to manage external stuff from Kubernetes. And we can refer to AWS as ACK, where you can define a Kubernetes resources, and then the controller interacts with the cloud API. It does not use any Terraform or something. So maybe a few layers of API, cloud API support would be helpful for that. And some number of CRDs, like you define, for example, AWS database CRD resource, and then somehow manage it. Because running
that
a
could be
Terraform workers.
that could
Yeah,
be
please go
some
on.
external library which can be connected to Cozystack. For example, what if you want to use Cozystack to manage just cloud resources as a central control point for it? You can install simple Cozystack dashboard and just put all the providers you have into this control plane and manage it through the Kubernetes API. That might work, but from the other perspective, why not simply using the tofu controller directly? Yeah, we can imagine why we actually created this API on top of Fluxcd. The main reason was to limitations in Kubernetes or back model. For example, we had no option to limit users to use virtual machines, but use other databases because from the Kubernetes perspective, all is Helm releases. So we created this additional layer of the abstractions using aggregation API layer just to have different kinds for every particular application. In case of Tofu and Terraform, that probably might have some value, but I actually don't see it very close. Right.
Okay, looks like we need to think about it for the next 2 weeks and discuss it one more time, maybe. That's a
please
huge topic.
prepare proposal with use cases, and then we can triage it. Could you please give me a screen share? Yeah, thank you. Yeah, Miroslav just sent a link to open Oreo. Never heard about it. Is that solution for IDP? All right, I'll take a look. Thank you. Okay, and the last topic we have today is discussion on improving the pipeline. And actually, I got a really cool idea that for now we have pipeline running for 1.5 hours. Not very stable. Sometimes something can go wrong. The idea was, so yeah, during this pipeline, we create 3 virtual machines. We install Talos Linux on them, then install Cozystack, and test all the applications one by one. The idea was to split this pipeline and preserve the state of those virtual machines. For example, when we create a release, we can also prepare a testing image which has virtual machines with pre-installed Cozystack. And then when we run tests, we can just download their images and run as it is without waiting for installation and for the installing Talos Linux and Cozystack. This way we can run tests even in parallel. So run few runners which will test different things. What do you think about it?
I don't get how you will keep all the versions of our applications in sync. Like many of our CI run in pull requests for main, and main may be very different from some latest release or something, and we can just use pre-built snapshots or images. So what do you think about versions and working with them, rebuilding them? Like when?
Yeah, that's the point. I didn't think about it. I just created testing pipeline to prove if it works or not. This pipeline just includes steps. One step was installing Cozystack and preserve the virtual machine states to OCI. And the second was downloading it and running end-to-end tests on top of it. But in fact, if inspec says this doesn't, it should be split to 2 different stages. So the stage 1 when we build the vault, and we need probably somehow test it to make it working only on yeah, you mean that every pull request you rebuild all the images? Because if we rebuild just part of them, that's not a problem. We just apply new Cozystack configuration and it re-rolls just these images. But maybe I'm wrong.
We actually now don't have partial updates of some images, because like release of Cozystack, it has all images always rebuilt. And if you like have some snapshot of cluster, you spin it up, it will take some time to boot, to reconcile all the resources in the running state, and then you update some components or all of the components, and it will take another time to reconcile and keep it running. So maybe it will be more, it will be longer than our current pipeline. So I don't know. I saw your pull requests and I already post some my questions for you, and I think we may discuss it like offline in pull request.
Yeah. I just collecting the thoughts regarding this. This PR just a draft. I don't want to make it merged. That was just proof if it works or not. But that looks like we have more general problem that every time we rebuild all the images and it doesn't look like it should be. I would really consider using some external cache mechanisms. As far I know, BuildX also has option to have aggressive caching on. And this cache can be stored directly in OCI. So anytime when we build any images, it will not rebuild it directly. It will reuse cached layers if nothing changed. And in this way, we'll get the same hash, same digest, which will not be rolled out on a new cluster. That looks like the thing we need to solve first.
We have, as far as I know, we have Docker caching when building, and it's not speed up so much. If you want, I can now tell you all about what I've already done with CI and what I plan to do to speed it up.
Yes, please.
Initially, my idea was to bring full end-to-end tests to only releases and maybe nightly main. And in specific PRs, often not all resource touched. And for example, PR of updating Redis operator, and we need to build only that parts of the system that interacts with Redis and only test Redis. So it will be much less work to do in CI. I have pull request number 3559, where I propose test impact analysis end-to-end tests approach. And it will be merged soon, I hope. For now, I brought new Flux 2.8 with new Helm controller with Helm 4 and completely new system of determining ready state of applications. Like now, if we apply some custom resource that just requests some resource to be provided by operator, and our Helm release custom resource is instantly ready. And we don't know if underlying resources are running or not.
All right.
And in Flux 2.8, we when we update to it, it will use case status and extended rules for any custom resource. We can write our custom rules like that kind of resource assumed running and ready when that metric of that resource are in some value. So I now one second.
You want to share a screen?
Actually, no, I can't share a screen now. I search for a number of pull requests. Please open 2602. It is update of Flux. It's quite big because it needed many system-wide updates for new ready logic. I break some of dependency loops that created by that upgrade, and main improvement in this PR, except main upgrade, is splitting seaweed to seaweed up and seaweed DB, and tracking both of that applications with custom rules. If you open like the packages extra, and you can see here seaweedfs DB with here health check expressions, and there is specific expressions for this specific Helm release. Like it has underlying CNPG cluster, and it has 3 states, like in progress, failed, and current. Current, it's like ready. And we can tune it for every our application and be aware of application statuses more broadly than now with old Flux and old Helm.
That looks so cool. I didn't know that these features even exist. Yeah, Kingdom also post to some information into chat. I'll copy paste into our discussion sheet. And we have a question from Nikita.
Yes. So I agree with Daniel that this is a cool improvement, something like custom readiness and probes and something like that. But he was talking about speeding up tests, and I was thinking that the great improvement would be to separate types of tests that you run now. So now for each commit, you run end-to-end test when you install all the system, and then you wait for all the components to be up. And it seems to me that only releases need that. So regular commits like updating component version and something like that should just spin a couple of containers and then run select one or something like that, like really simple probes. And I think that separating those commits in types and running different types of tests for each commit would make a great improvement in speed and maybe reliability in some way, because you can see the results in a shorter time. So that is my thought.
Yeah, I agree. And Andrei, if you can open 2559 pull request, we can see that this logic you, Nikita, said is already drafted as this PR.
Awesome.
I didn't brought it to review yet, and not so much tested before because I put more effort into stabilizing current test suite. But after upgrading Flux, I think I managed to merge.
Would you be interested to review this PR, Nikita?
Oh, yeah. I'm not sure about running tests on it, but I will definitely take a look at it.
Thank you. All right, I'll post few links to these PRs into our document.
Thank you.
Thank you all. We are running out of time. See you in 2 weeks, the same time. Bye.
Thank you. Bye-bye. I think we have a great discussion.
Yeah, thank you.